Alright guys, in this video I'm gonna show you how we calculate the equilibrium constant based on the free energy change of a reaction. Here let's take a look at this reaction. You have those standard molar free energy for those reactants and products. It's asking you to calculate the equilibrium constant for this reaction. Okay, so here the equation we need is right here. Delta G 0 equals to negative RT ln K. R is the gas constant, T is the temperature in Kelvin, and K is the equilibrium constant. First thing is, in this question, we do have to calculate the free energy change for this reaction first. Since the delta GF for the reactants and products are available, let's use the second equation to do the calculation. Delta G reaction equals to, we deal with the products first. You have 1 mole of the calcium hydroxide times the corresponding delta GF for calcium hydroxide, that is negative 897.5 kilojoule per mole. Okay. Second product is hydrogen. 1 mole of hydrogen, but because it's a free element, the delta GF for a free element usually it's 0, and it's not given here. It's because it's 0. Okay, so it's 0 kilojoule per mole. All right, these are the two products minus the two reactants. First one, let's deal with the calcium. 1 mole of the calcium. Again, because this is a free element, delta GF for the free element, usually it's 0, so 0 kilojoule per mole, plus the 2 equivalent of water, or 2 mole of water, the corresponding GF. For water, the liquid water is this much, so that is negative 237.1 kilojoule per mole. Okay, so now if you do the calculation, you get this value, negative 423.3 kilojoule. As you can see, this is a negative delta G reaction, so it's a spontaneous process. But that's not our focus. Our focus is to find out the equilibrium constant. So we plug this value in this equation, okay, to find out the length, to find out the K. What I got here is negative 423.3 kilojoule as a delta G reaction. All right, that should be equal to the negative RT ln K. However, if you remember the unit of the R, the gas constant, that is 8.314 joule per K per mole. Okay, and we have a kilojoule here, so we have to convert this kilojoule to joule before we do any calculation. All right, so we have to do this first, and then that equals to negative, now it's R, the gas constant. It will be given in your exam, okay? So you don't need to remember it, but it's because of the units. You have to be careful. Joule per K per mole for gas constant, and times 298 Kelvin. All right, and ln K. And I'm gonna move to this area to continue my calculation. And if you do the calculation here, and if you divide this whole item, divide the two sides by the whole item here, you get ln K equals to 170.9. And then you raise the two sides to the exponent position of E. And then you got your value of K. Okay, because E to the ln, you can cancel the ln and E. So the K equals to E to the 170.9. and if you can use your calculator, then you will find out the value of this number is 1.586 times 10 to the 74. It's a huge number, okay? It tells us this fraction is product favored. And sometimes if this value is too big, and if you do the calculation on your computer or on your calculator, it will give you an error message. So in that case, it's okay if you stay right here. Okay, I understand that problem. All right. Let me know if you have any questions. Thanks.